I sure am. Today we are learning about Vera Rubin. Vera Rubin was an astronomer, which means she studied the night sky and everything that is involved within the night sky. She loved to lay on her back when it was dark out and look up at the beautiful stars. She was born in the 1930s in Philadelphia, and her dad built her first cardboard telescope. When we look at the stars in the sky, they make recognizable patterns called constellations. My favorite constellation is Ursa Major because it looks like a bear, but there's lots you'd probably recognize like Little Dipper, Big Dipper, or Orion's Belt. In our galaxy, the Milky Way, there are over 300 billion stars. 300 billion! That is so many stars! It's even hard to understand what that means. Let's go find out. Let's go learn about astronomy, stars, and the beautiful night sky. When we talk about stars in the universe, we need to think in terms of really big concepts, astronomical concepts, because these are huge things that are really far away from us. We use the term light year. Light year is a measure of distance. So think centimeter, meter, kilometer. Light year is a distance. When we turn on a light switch or a flashlight, sometimes it seems like the light instantly is on, but it actually takes time from light from the bulb to get to our eyes. So, light year is the amount of time light travels in 1 year. So if I turned on a light switch and I set a timer for 1 year, how far does the light get? It actually gets 9.7 trillion kilometers. If you started running on January 1st and didn't stop running until December 31st at midnight, do you think you could run 9.7 trillion kilometers? I don't think so. That's how fast light is. That's why we have expressions like the speed of light. We talk about how far things are from us in the night sky using light years. So galaxies are light years away, over 9.7 trillion kilometers away. Now that's just one light year. The closest galaxy to us is 25,000 light years away. That's 25,000 times 9.7 trillion kilometers. So that's super far away, and that's just the closest galaxy. So when we talk about light years and space and astronomical distance, we're talking about things that are super far away. And in our galaxy, wait, what really is a galaxy? I have a lot of questions. Pipette! Hi, Pipette. How are you doing today?
Oh, I'm doing well, Jenna. You know what?
What?
I just finished baking some cookies.
Did you bring me any?
They're still hot.
Okay.
Wait a few minutes.
Okay. We'll wait till after the episode to eat those cookies. How are you doing today?
Oh, I'm spectacular.
Me too. In fact, today we are learning about Vera Rubin.
Yes, she earned her PhD and worked a lot with rotating galaxies.
Yes, that is my question, Pipette. What exactly is a galaxy?
A galaxy is a huge collection of gas, dust, and billions of stars. And their solar systems. And they're all held together by gravity.
Okay, so galaxies are the things made up of planets and solar systems and stars. I think I get that. It's like a location, and our location is the Milky Way galaxy.
Exactly. You can think of it like an address.
Like an address?
Okay, if I wanted to write a letter to someone who lives on Earth but in a different city, I would be able to mail them a letter with their address.
Oh, Pipette, I didn't know that puppets sent letters.
How do you think I get all the newest recipes from?
Of course. Okay, so you want to send a letter to someone on the planet Earth, but in a different city. Of course, you'd write down their address.
Exactly. But say if I wanted to send a letter to someone in a different galaxy.
Oh, like an astronomical address.
Exactly. I am so happy you brought this up today because you know what?
What?
My friend from a very far away galaxy just sent me a letter.
Should we pull it out and look at the address?
Absolutely. I'll need some help. It is quite large.
I mean, if it's coming across all those galaxies, I'm sure it would be astronomical. You know what? I'll leave the jokes to Funny Bones. Let's pull out that letter. Okay, Pipette, we pulled out your letter. This is a huge letter, but it had to go a long way.
Oh, absolutely.
Let's read the address, and then I'll break it down for everybody, okay? We got 1089 Erlenmeyer Court, Saskatoon, Saskatchewan, Canada, Earth, the Solar System, Orion Arm, Milky Way, Local Group, Virgo Cluster, Virgo Supercluster, the Universe. Let's say it again. 1, 2, 3. The Universe. I bet, I love how we just jam together and have a good time. Okay, I'll break this down for you. 1089 Erlenmeyer Court. That's where we live.
Yes.
That's the address of this house. So if you want to send me any mail, send it here.
Oh.
In the city, Saskatoon, the province, Saskatchewan, the country, Canada, the planet, Earth. Now, we don't write Earth on mail we send on planet Earth because we all just assume that it's going to the planet Earth. But if I was on a different planet, I could write Mars, Jupiter, Saturn, whatever planet I'm on. We'd also include our postal code in this area, but we don't want you to be able to find us exactly for security reasons. Pipette's a pretty hot celebrity in the world of science. Next, we have the solar system. This is the area where all of our planets live. It's a very specific solar system. There's more than one type of group of planets. Ours is called the solar system. Orion Arm. This is where we are located in the Milky Way galaxy. In one of the spiral arms of the Milky Way galaxy, we have the Orion Arm. And then Milky Way is our galaxy. Local group is the group of galaxies in our area in the sky. Virgo cluster is a bigger cluster of local groups within the sky. Virgo supercluster is a bigger cluster of those clusters within the Milky Way, within our solar system, and the universe, meaning the exact thing we live in this universe, in this reality. So basically, it starts really specific, the exact house number that we are living in, and goes to the entire universe or the group of stars, so on and so on. So when you write your friend back, make sure you got a stamp for the exact area you're going to. And once the postage is paid, she should receive the letter. Hey, Pipette, what did she mail you in this huge letter?
A very secret recipe and some seeds for my garden.
Oh, I know gardening's one of your passions, Pipette. Hey, will you bake me that super secret recipe?
Absolutely.
Wonderful. Let's go learn more about galaxies. Now that we know what a galaxy is, let's learn more about them. This is what Vera did. She studied galaxies. There are 3 types of galaxies, and I'll break them down for you. Number 1, we have elliptical galaxies. This makes up 1/3 of all galaxies in the known universe. The largest elliptical galaxy is 300,000 light years across. That's huge. Remember, a light year is the amount of distance light travels in a year, 9.7 trillion kilometers. So it's 300,000 light years across. That's huge. The smallest type of elliptical galaxies are 3,000 light years across. These are more common than the large ones. These large ones are quite rare. These smaller galaxies, or dwarf galaxies, about 3,000 light years across. Now, elliptical galaxies are disc-shaped. My drawing sort of looks like a donut here, and that's kind of what it looks like. There's not actively forming stars in these galaxies, so these are old galaxies. Number 2, spiral galaxies. Now this is what Vera focused on, was orbiting and rotating spiral galaxies. They are disc-like galaxies that are flat, blue, and white with this yellow bulge in the middle made up of stardust and gas. Now, spiral galaxies are actively forming stars, which means stars are being born all the time. In elliptical galaxies, these are just old stars, not actively forming. Spiral galaxies, Milky Way, that's a spiral galaxy, and we're out on one of the arms in the Milky Way galaxy. Number 3, irregular galaxies. Now, my picture of a regular galaxy just looks like a clump of stars, just means they have no specific shape. Now, these are deep universe galaxies. If we think of light as taking time to get to us, we can think of looking at stars in the sky as looking back in time. It takes the light from the sun 8 minutes to reach us. So if the sun burnt out, we wouldn't know for 8 minutes for the amount of time the light takes to get to us. So these irregular galaxies are far, far, far away. So when we see them, we're seeing them back in time. If 100 years ago, the stars in all this galaxy shone very bright and then burnt out. Let's imagine that. 100 years ago, this galaxy we're looking at burnt out. Let's say it takes 200 years for the stars from this galaxy to reach our eye. Well, then we're looking at light that left this galaxy 100 years ago. So we won't know it's burnt out for another 100 years. That's why space and time are so closely related. So this is very early universe. Right now we're talking about spiral galaxies, just like the Milky Way, and that's what Vera studied. These are the 3 kinds. How interesting! Dark matter is a difficult idea to grasp because it's an abstract concept. I'll help you understand what that means. If I show you this flask of green liquid, you can see it, I can feel it in my hand, I can smell it, I can see that it's there, and it's proof that it's there. But what if I told you gravity is what is keeping it in the glass or keeping our feet on the ground? That's an abstract concept because you can't see gravity itself, but you see that gravity is acting on my body and the water and keeping us here standing on the earth. That's like dark matter. Dark matter is an abstract concept or thing that exists, but we can't really see it. We just trust that it exists, and scientists can prove that it exists between different calculations and theories. Let me break it down again for you. To understand this, we're going to need a book. I just grabbed this off my shelf of casual reading, Anesthesia and Coexisting Disease. This is the 4th edition. This explanation will work with the 1st and 3rd edition, not so much on the 2nd, but if you have any kind of book with words on the page, you'll be able to read along with me. So grab your book and pull it out. Can you read one sentence or one word on the page? Yeah, good job. I can read the words on these pages because these words are on the page. If you're thinking, okay, Jenna, I get where you're going, but what does this have to do with dark matter? If we think of the words that are on this page as the galaxy or as planets or stars, and if we think of the white paper underneath the words as dark matter, we're going to understand this concept. If I took the page away without the letters, I'm leaving the words, but I'm just taking the page away, you're not going to be able to understand what the words say. It'll just be a pile of letters and ink, or just a pile of planets and stars. Dark matter is the backdrop on which the universe is on, or the page that the words are on. And it works with gravity. That's really what's acting upon these planets and making them spin and rotate, is gravity. Dark matter creates the gravitational pull that makes the galaxies spin. Whoa, that was a lot of science. And I'm not asking you to just understand this blindly and believe what I say. You can discover your own theory about why gravity exists or what keeps the planets spinning. Vera's theory was dark matter, and that is what a lot of scientists believe today. You can read more on this, but make sure you have a page to read it on. That was a lot of science, and if you didn't get that, that's okay. I think it's time for a fun experiment. Okay, for our experiment, we're making a galaxy in a jar. It's also known as a sensory jar, so it's just something fun to play with and look at to make us feel good, and it's a big craft project we can do together. I'll go through the materials with you, build one with you, and then we can share our jars. First, we're going to need a glass jar. This used to hold pasta sauce. So if you don't have all the ingredients right now, that's okay. Maybe just ask your parent or person you live with to make you some pasta next time and add extra sauce. Get the jar and make sure it's cleaned all the way. This is just a mason jar I'm holding. Next, get some water. I have my jug of water here. And here I have some paints. I even have some icing. This is a little bit of an experiment. The ingredients say don't use this, but I'm gonna try anyway. And I have some glitter. And most important, some kind of cotton ball. This might seem weird, but this is gonna be our cloud and gas structure within our galaxy. This is actually stuffing from dog toys that my dog destroyed. You can buy cotton balls at the store, order them online, or stab one of your pillows with a knife and steal all the cotton from inside. Maybe get an adult to do that for you. Or if you have a dog, just pick up the fluff and recycle the material within them. And then you can think of anything else you want in your galaxy. Beads, glitter, anything you want. Think creatively. Now, I haven't done this before yet, so this is my first time making a galaxy. Let's see how it turns out. First, we're gonna fill our jar halfway with water. This is just regular water that I got from the tap. Then we're gonna pick a color of paint. Let's go with purple here. And I'm gonna squeeze some into the jar. Blah, blah, blah. Makes that funny gushy sound. I'm taking a chopstick. You can use a spoon. I just don't want to get everything all painty. Mix that up. Now I'm taking my cotton balls and I really want to stretch them out. Sometimes when you buy them brand new, they're quite tightly wound. Luckily, my dog has chewed these all to pieces already, so really, he's the scientist here. So you can pull all these clouds apart and stuff those into the jar and push it down into the water. There we go. We're starting to get those clouds. Ooh, let's add some glitter here in this very fancy glitter I've gotten. I just took it right off, but we should be generous with the beauty of it all. Add it in. I'm just going to get some of those finer crystals in there. Perfect. And oh, this is fun. I just get to throw everything into the container. These are the stars in our galaxy that light up the night sky. Now, add the rest of your water. Boop, 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 boop. Leave a little bit of room there. Okay, so we have purple. Maybe we should add some turquoise. You can add different colors of paint if you want, so be generous with the paint. Woo, makes that blobby noise. And maybe a little bit of gold. That would be, sometimes when you look up the stars, we see that gold. It gives us a little bit of extra glitter. Now, you may think we have enough clouds, but I'm going to mix that up so I don't get globs as we go. And then I'm going to add more of this and mix it up. And you know what they always say? Be generous with the glitter. So I'm going to add a lot of glitter in there because we want a lot of stars. Oh, over 300 billion stars in the night sky. I did mention that earlier. Top it off with water. Maybe just a little bit of yellow in there. Oh, make sure we put our caps tight back on our paint so we can reuse them for later experiments. Mix that in. Oh, I think our galaxy is really coming together. Now put that lid securely on and see what else you need to add. Okay, shake it up. I think I need a little bit more water because the cotton is going to absorb some of that water. So you can fill it right to the top. If you spill, that's okay. Okay, mine's kind of separating in a bit. Maybe I put too much cotton in there. Can really shake it up. Oh, if you look closely, you can kind of see the gas clouds and the way the galaxy spins and turns. It's pretty cool to look at up close. I can see the different colors of paint that represent different gas structures and all the clouds within it. Look, when the water comes away, I can see the structure of these gas clouds. That's so cool. It actually does kind of look like the structure of the stars we see in the sky when we look at them up close. See, I thought I made a mistake by adding too much cotton, but there's actually beauty in mistakes. This way I can see structures of the stars. Oh, that was really fun. Let's see how your jar turned out.
Back to me, Funny Bones, with some hilarious jokes. You'd think I'd run out of jokes, but the material is endless. What does Jupiter use to keep its jeans on? An asteroid belt! Why did the cow go to space? To see the Milky Way. How do you know when the moon has had enough? It looks quite full. Why did the sun go to school? To get brighter. What is a light year? The same as a regular year, but with less calories.
I love ending a day of science with a good old laugh break. Thanks, Funny Bones. And thank you for sticking around with me today and learning about the astronomer Vera Rubin. Her dream was to go to the Andromeda galaxy, which is millions and millions of light years away, and look back on our galaxy and see what it would look like in the night sky. That would be pretty cool to be able to travel all around space. There's so much to learn about astronomy and so many things I can teach you about. If you like stars, planets, gravity, dark matter, I encourage you to do more research in the areas that interest you and spark your passion. Vera grew on to be an amazing astronomer, and she led many, many scientists in the field of astronomy, especially females, and her 4 children even all became scientists. I'd hate to be that 5th child who wanted to be an actor, just like me. Thanks for sticking around, and I'll see you next time. Bye, everybody!